In this video, I want to talk about RLA, FLA, and LRA. Okay, now I just put a note on here. It's not just alphabet soup. To properly diagnose air conditioning systems, you do need to know about what these all stand for and what you're looking for. It's pretty important. So, amperage, we have to remember, is a measure of current. It's how fast or the speed of electrons moving through the conductor. All loads, these are electrical devices that do work, have resistance. This resistance with the voltage creates current. This is a very simplified explanation. But again, current is how fast the electrons are moving. FLA stands for full load amperage. It's the maximum amperage a motor will pull under normal operating conditions. The key word here is maximum, and as we go through this conversation, I want you to remember that. RLA is the rated load amps. Okay, it's the rated amperage that a motor will pull under normal operating conditions. Now again, these are high numbers. A motor can always pull under these numbers, but it shouldn't be pulling over these numbers or the windings are eventually going to go bad. LRA is the locked rotor amperage. This is the maximum amperage the motor will pull for a split second before the rotor starts turning. It is also the maximum amperage that the motor will pull if the rotor does not turn. Okay, so it's a locked up. Okay, the motor is not moving. We've energized it, and it's pulling amperage. The data plate on the motor or the equipment will show the RLA or FLA and the LRA of a motor. Okay, so you have to go look at the data plates to find out what these values are. Here's an example. Okay, if we look at this data plate, okay, you're going to see that we have compressor LRA 72.6, compressor RLA 13.6, fan motor 1.40, maximum fuse 30 amps, and minimum circuit amps 18.3. Now, what does this all tell us? Okay, the LRA, that's the initial start amperage for a split second with that compressor, or if the compressor fails mechanically and gets locked up, is going to be 72.6 amps. The RLA, this is the rated amperage of the compressor, is 13.6. The fan motor has an FLA of 1.4. Doesn't include an LRA because it's a smaller motor. They a lot of times don't include those. Maximum fuse size is 30 amps and minimum circuit amperage is 18.3. Okay, so the bottom line here is that if my compressor locks up, it's going to blow the breaker. 72.6 is higher than 30 amps. Normal operating conditions for the entire piece of equipment, okay, is going to be under 18.3 amps. That's my minimum circuit amperage. Okay, so the wiring has to be designed to handle a minimum of 18.3 amps. But because the fuse size is 30 amps, we're going to size the wire for that 30 amps. Now, it's very important to see rated versus measured. Measured amperage will change based on the amount of work being performed and the temperature of that motor. Let me say that again. Measured amperage will change based on the amount of work being performed and the temperature of the motor. For fan motors, this will change based on the weight and the volume of the air being moved. The blower motors inside a piece of equipment change based on the weight and the volume of the air being moved. Hotter, humid air, okay. Colder, humid air, colder, dry air, all has different properties, and that will change the amperages of the motor being driving the shaft. For compressor motors, the amperage is going to change based on the temperature of the evaporator and the discharge pressure, because again, the refrigerant pressures make a big difference. Measured amperages, amperages that are too high, check the capacitors, check for wiring issues, rust, corrosion, improper connections, and heat. Check for bad motor bearings. Check for motors overheating. In compressors, high pressures could be improper lubrication, not enough oil. Okay, oil traps may be in the evaporator. Okay, amperages that are too high, something is causing it. Compressor amperages deserve some additional attention because the motors are many times not accessible. Also, there's additional factors other than motors that can affect compressor amperages. Measured amperages that are lower than the RLA or FLA just means the motor's not performing to the maximum workload. Okay, don't condemn a motor for low amperages. Low amperages alone are not the sign of a bad motor or compressor. And I've been seeing that a lot in the field lately. A lot of people are condemning motors and compressors because the amperages are too low. A low amperage, as long as it's like not zero, okay, low amperage motors are still good. They're working. Low compressor amperages, why? We need to check further. Low amperages in compressors can be caused by undercharge of refrigerant, cool ambient temperatures, low load on the evaporator. Might have mechanical compressor problems. Those will show on gauge readings. Bad valves. Scroll compressors excluded from this. Okay, you might have a high-low side, low-high side. It's not pumping properly. Could have a broken crankshaft. No pressure differential equals zero pressures over 0 psi. Why do I say over 0 psi? Because if there's no refrigerant in a system, there's no load on that compressor. So just be careful on that. If you think you have a bad compressor, throw your gauges on to see what it actually is, because it might actually be pumping.